welcome. So basically I've built a software, sort of like a software using Matlab, based on the Perceptron algorithm for the AI subject. So basically you can download these files from the description below. Okay, you can just follow along. Of course, to use this software, you don't have to copy it exactly. You can always modify your own version and that suit your own use lah. And one thing I can explain over here is I need to explain over here is if your weight is different, your initial weight is different, like W1, W2 and W3, they are all different. You need to comment this part and uncomment this part, okay, so that you can manually input for each weight. Okay, and if you don't, because currently we all the examples that we have they have the same initial weight. Okay, so let's get started with the demo. Okay, and so you first started with a setup file. Okay, and then you can just run it. So it will ask for the number of inputs. So if you observe over here, in this end we have 3 inputs: x1, x2 and x3. So we just key in 3. Let me put side by side. Okay, and then our weight is 0.5, a negative 0.5. And our alpha is 0.25, and our theta is 0.1, and our b is 1, which is set over here. And let's get started with the inputs, all the inputs over here. Sometimes it could be 0 or it could be very different, because it depends on the pattern that you need. This one is apparently is for OR, so you have this kind of inputs and of course. Okay, of course you have if you found another pattern that you can try it out yourself. You I mean, there is a method that you don't have to manually input all the possible inputs over here, x1, x2, x3. You can generate it by yourself automatically, but I am lazy, so so I just create this kind of a pattern. So for here, you can see this x11. So basically it's this one. Okay, x11, x12, x13, sort of like a matrix. Okay, and this is t1. Okay, and this is x21, x22, x23, and t2. So if you can observe over here. So let's key in the numbers: -1, -1, -1, and t1 is -1, and x21 is -1, -1, 1, 1, and -1, 1, -1, 1, -1, 1, 1, 1. And just in case you lost, you can always check back here, number 5, 1, so I can see that, okay, 1, 2, 3, 4, 5, so it should be this one. Okay, I can start over here. Okay, I can just 1, -1, -1, 1, 1, -1. Oops, so I mistake over here that I can change it manually. For 6, 3 is 1, and 1, 1, 1, -1, 1, 1, 1, 1, 1. Okay, so you can see that my x62, so I can always go and x62 is equals to x62 equals to -1. Okay, -1. Okay, so I can just check it over here and just and always check it over here in the x doubles. Okay, and just check it over here. Okay, correct. Now I already corrected. Alright, so okay, good. The good thing is over here is it will summarize everything that you have input. So you can check your learning rate is 0.25, the threshold is 0.1, and W1 is -0.5. Yeah, and initial weight are all negative 0.5, and B is 1. And then you can see your tables over here, x1, x2, x3, and t. Okay. And then we did some correction over here. We can always go there. And yeah. So once you have keyed in all the tables, you can go to the starttraining.m, and over here, basically, you just have to run it, okay? And it will come out with a report like this. So when I run it the first time, so you can see in this report, you can see that this is the first epoch, and the first iteration, the S value is 2.5, Y is 1, B is 0.75. So how do I verify whether it's correct or not? You can always check it over here, because this one we have the answer ready. So in the epoch number 1, the first iteration, it should be like this. So let's check over here. We have the first one is the first the S1, first iteration S is 2.5, Y is 1, B is 0.75, and the table over here weight is negative 0.25, all are negative 0.25. And if you look at this pattern, as here we have 1, 1, 0.5. So if you scroll down a little bit, so you can see the second iteration S1 is 1, 1, 0.5, and then go on and so on and so forth lah, until the last one, the 8th, the 8th. I mean, yeah, until the 8th, the last one, the last iteration. So the last iteration, it says the S is equals to 0, which is true. And then Y is equal to 0, B equals to 1, and then the last weights are all zeros. Okay, you can always enlarge over here, you can see. Yeah, W1, W2, W3. And if you want to run for the second epoch, you can just run again this code, and then it will print. This is the second epoch. Why do I manually requires you to run this code manually another time? Because you need to check all these numbers, and then you need to put it on, handwritten it, right? So I was thinking that, oh, maybe you can try like this. So you can see the second epoch also correct. You have 1, 1, 0.51, 1, 1, 0.51, and then all the Y's are 1, yeah, and the B's are the first B. This one was the previous B, so it should be here. And starting this epoch, this second epoch, it's all 0.75. So you can see all 0.5, and the weights are all 0.25. Okay, correct. And you can just run epoch 3. Okay, epoch 3, you have the S starting with zeros. You have 0, 0, 0, 2, 0, 0, 0, 0, 2, 0, and then you have the Y is 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and then so on and so forth. You can see that 0.5, 0.75, 1, 1, 1.25, and so on and so forth. So until you, let's do, now we are at epoch 3, right? So you can just run another 2 times, and then you check with the epoch 5. Run 2 times, okay? Now we have epoch number 5 over here, and you can check. The answer is still is correct, okay? You can check the answer is actually correct. So yeah, I hope this software can actually help you to develop your own software. Try not to copy or just change the variable's name. Try to analyze it on how do I build it, and you can create your own software like this. Okay. Thank you for watching. See you next time.